A very good morning to one and all present here. Here I am going to discuss about introduction to optical fiber communication. Introduction to optical fiber communication. Before going to discuss the topic optical fiber communication, we must know what is communication. So all of you know what is communication, because being a ECE students, you must know what is communication. Transformation of information from one point to another, that is called communication. You may be studying different type of communication so far. Now you under 7th semester, you have studied different communications: wired communication, wireless communication, satellite communication. Okay, lot of things you may be studying. So what is the difference between wired and wireless communication? Why we go for optical communication? That we must realize. So during wired communication, you may use different type of cables. Coaxial cable you may use and a twisted path. So due to some drawbacks, we go for optical fiber communication. That is optical cable. That is optical cable. This is your normal coaxial cable. This is normal coaxial cable. This is the repeaters. Okay. So you may use this kind of cables during last decades. We used coaxial cable. After that evolution of coaxial cable, we used twisted path cables. That is twisted path cables. You can see this. This is compared to coaxial, it have more advantage. So even though these cables are affected by EMI. EMI in the sense inter-simple interference. Sorry, electromagnetic interference. Okay. Due to that, the data loss will be more compared to fiber optic communication. So this is your twisted path. So this is your normal optical fiber cable structure. Okay, you can see what is in the optical fiber cable. The outermost you are having core region. All lights are propagated inside the core region. It is denoted by N1, small N1. N1 is core axis. N1 is core axis. Okay, that is core. After that you are having cladding. So why we are going to use cladding is to support the core. To support the core or strengthen the core. That's why they were having cladding section. Okay. After that, they are having some other material, strengthen the material, they are having buffer coatings, outer jackets. So like that, it is constructed optical fiber. Okay. So why we go for optics? Compared to last class, I have discussed this. Why we go for optics? Because compared to other communication, optical communication is very fast because it is a light wave communication. It is a light wave communication. That's why it's called it as optics. All data are transmitted in the form of light. So due to that, the data loss also very less. The transmission speed is very high. The transmission speed is very high compared to other wired communication. So during and beginning of the optical communication, the repeater spacing is very less. Nowadays, we are using for each 1 lakh kilometers we are using repeaters. The repeater spacing is increased nowadays. So this is your normal fiber optic cable construction I have mentioned earlier. So it will look like this. Optical fiber will be seen in different things. In roadside, you may be seeing this kind of cables. So for BSNL or NTNL or Airtel, Jio, they were used for optical cables for transmission of data. For transmission of data from one point to another. Okay, right. Next we will go for the introduction. That is how we will go for establish the simple optical fiber communication link, or how will you establish optical link, or you can say elements of optical fiber communication. Elements of optical fiber communication. How we will form a optical fiber communication network. That's why I have mentioned the elements of optical fiber communication. Already discussed in earlier. Okay. So this is your electrical input. This is your electrical input. So electrical input is applied to the drive circuit. Electrical input is applied to the drive circuit. So drive circuit will convert the electrical pulses into adequate level to the light source. Based on the level, it will convert the electrical pulses to the light source. Light source in the sense, here you are having LED or laser, whatever it may be, different kind of light sources, or you can say optical sources. Optical sources used to generate the optical signals, light signals. So the electrical pulse, before giving to the electrical pulse, your normal audio or video image will be converted into electrical pulses. Converted into electrical pulses. Then only this pulse will be given to the optical source or LED or light source. Directly we cannot send the information. That is, we cannot send direct audio or video image to the optical source, that is light source. That's why it is converted like a transducer. Okay. So here converter thing is given to the light source. Here you may be used to a different optical sources. So this section is called as transmitter section. I have mentioned this section is called as transmitter side. So in this transmitter section consists of drive circuit followed by optical source or light source. So drive circuit followed by light source is transmitter section. After that, the signal converter light signal is given to the optical fiber. Here you are having small connector. This is called connector to join the optical fiber with your transmitter section. Like couplers, like that. You are going to join this connector. With the help of connector, you can add the fiber optic cable. This is your fiber optic cable. After that, some particular amount of distance, we have to include one more length of cable. So for that, we are having splice. I have mentioned optical splice. So what is optical splice? So this is used to connect or budding two fibers together. That is called optical splicing. Splicing in the sense, joining two fibers together. Okay, that is actually this is a process, a very big process for splicing. With the help of splicing, there is low level of loss will be occurred during the transmission. That's why here they are spliced between these fibers. So the further they are used optical splice. Then the light travels via optical fiber cable. Next we are having this section. Okay, regenerator section you can see. Here you are having optical coupler. This is called optical coupler or splitter. So splitter is used to split the optical signals, light signals. Splitter is used to split the light signals. Here you can see this optical splitter or beam splitter. We can say this one beam is sent to this receiver section. Another one is some other equipments. We can use other equipments also. Okay. So here the optical is here given to the optical receiver. This receiver is used to convert the optical signal into electrical form. It is used to convert the optical signal, that is light signal, into electrical form. That's why I am mentioning here this line is thick line. You can see this is optical fiber. This thick line is called electrical signal. That's why I have mentioned different line dot thick dot line. So this is electrical signal. So that is applied to the amplifier. Okay, that is applied to the amplifier. This electrical signal, that is converted electrical signal, is applied to the amplifier. So which is used to amplify the signal, received signal, which is used to amplify the received signal. Then it is given to optical transmitter. Optical transmitter. What it will do in the sense, the optical transmitter will receive the amplified signal and it will convert to the light source, light signals. Then it is given to your optical fiber. You are having some connector, splicing. After that, you have optical amplifier to strengthen the signal. Before that, you are having some pre-amplifiers. Then it's entered into the receiver side. So in this receiver side, you are having optical receivers. So for receiver section, I already told what are the optical receivers. I mean optical detectors. We are having photo detector PD, avalanche photodiode. Okay, these are all optical detectors. With the help of this, we can detect the optical signal. We can detect the optical signal. Here you are having photo detector. With the help of the photo detector, we can detect the optical signal. Then whenever the detection occurs, definitely there will be a loss. Okay, if you go for any kind of transmission or modulation or amplification, that means after that there will be a loss. That's why here we are used amplifiers to amplify the adequate level of signals. Okay, then we are amplified. Then amplified signal goes to signal restorer, which will restore the original shape of the signal. Because during the amplification, we cannot say exact amplification occur. So with the help of signal restorer, we can reshape the signal adequate level and required level. That's why we are using signal generator. Then it is given to, then the output of this electrical is given to the destination. So like that, a simple optical fiber communication takes place. Like that, a simple optical fiber communication takes place. Okay. So next we will see on okay. We'll see on board. Okay. So we know different kind of fibers. Okay, different kind of fibers. That is single mode fiber. Another one is multi-mode fiber. Single mode fiber and multi-mode fiber. What is mode? Before that, you must know what is mode. Mode means path. Mode means path. So in single mode fiber, you are having only single path. In single mode fiber, you are having single path. That is, this is your normal optical fiber. Okay, this is your core. So here you are having only one path. Okay, only one path. So that's why it is single mode fiber. So the single mode fiber have low loss and more information can be transmitted. Okay, the data loss will be very less. Okay, this is single mode fiber, but we can transmit only one path. Okay, whereas M means multi-mode fiber. So multi-mode fiber in the sense it has multiple paths, more than one path. So light travel like this. This is the simple penetration of multi-mode fiber. Here you can see this different kind of modes travel inside the core axis. This is multi-mode fiber. So that's all about types of fiber. Next, after that, the classification. So before going to classification, okay, we must know what is refraction. What is reflection? So you know that what is reflection? Okay, here you can consider a light source. With the help of light source, light is strike out this phase. The angle at which the light can strike the surface with respect to perpendicular line. This is called as angle of incidence. This is called as angle of incidence. The angle at which the light can strike out the surface with respect to normal angle. This is called angle of incidence. It is denoted by phi 1. Phi 1. Okay. Similarly, the angle at which light can reflect back to the surface. This is called phi 2. This is called phi 2. That is angle of reflection. Angle of reflection. So this is very important. The angle of incidence phi 1 is equal to angle of reflection. Okay. Without this condition, we cannot travel or we cannot penetrate this signal inside the core of the optical fiber. Core of the optical fiber. Why in the sense? Why in the sense? So because in optical fiber, okay, the light travel like this. You can see zigzag manner. Okay, so when the angle of incidence or angle of reflection is not in same, definitely the light will be refracted out of the core region. Refracted out of the core region. So that's why the angle of incidence and angle of reflection must be same. Angle of incidence and angle of reflection must be same. Without this, we cannot send the information from one point to another point. So that's why the phi 1 and phi 2 is equal to same. Okay. Next. So what is an acceptance angle? What is an acceptance angle? So what is acceptance angle in the sense? It is toward optical fiber cable. Okay. So the angle at which light can penetrate inside the core axis. So the angle at which the light can penetrate to the core axis of the fiber, that is called acceptance angle. That is acceptance angle only. The light can travel. Without other angle, the light cannot penetrate inside the fiber. Each fiber having a separate acceptance angle. This is denoted by theta A. Theta A. This is acceptance angle. Okay. I hope we are going to define the term acceptance angle in the sense the angle at which the light can penetrate inside the fiber. Inside the fiber optic cable, that is called acceptance angle. Okay. Next we will look on to the classification of fiber. Classification of fiber. So in fiber classified into two types. Okay. Step index fiber. Another one is graded index fiber. Step index fiber. Another one is graded index fiber. So what is step index fiber? What is graded index fiber? It's very simple. Okay. In step index fiber, okay, the core refractive index is uniform. This is core. Okay. Core refractive index is uniform in step index fiber. In step index fiber, the core refractive index is uniform. So step index fiber also having single mode fiber, multi-mode fiber. So whereas if you look on the graded index fiber, in graded index fiber, the core refractive index is not uniform because the core refractive index is varied based on the radial distance of the fiber. This is the major difference between step index fiber and graded index fiber. Okay, this is major difference between step index fiber and graded index fiber. Okay, so far we have discussed about what is optical fiber, why we go for optics, what is the necessity to implement an optical link. Okay, what are the elements of optical fibers? Okay, after that, basic laws of angle of reflection, angle of incidence, types of fibers and classification of optical fibers for this section. Okay, thank you.